This one is 7.2, looking into the finite and infinite series. So first of all, let's try to define what is series. Series, meaning to say, is series refers to the sum. Please take note, the sum of the sequence. Okay, the sum of the sequence, that is series. So for example, you have the sequence of 2n plus 1, wherein the sequence here is 3, 5, 7, 9, 11. So this one here, when you say series, sometimes we are using the symbol S. Okay, we use the symbol S. So for example, S. In other book we use S. Okay, in other book we use sigma. Let's try first the symbol S. So when you say S, for example, S2. S2 means 3 plus 5, the sum of two terms, that is 8. When you say S3, S3 means the sum of three terms, so that is 3 plus 5 plus 7. So that one will give you 15. So therefore S5 means 3 plus 5 plus 7 plus 9 plus 11. So that's the meaning of S5, which is equal to 35. So what about using the sigma notation? Again, this is the sigma notation. So in the sigma notation, we use the symbol like this. So let's write the S2, okay? In sigma notation, the S2 symbolized like this. The sigma, okay, it is read as the sigma of 2r plus 1. The 2r plus 1 is actually this one. Okay, we just change the n to r. If sigma 2, meaning from r is equal to the first term up to the second term. And the answer to this one is 8, because it means the sum of the first two terms. Again, in other book, this is the symbol. In other book, this is the symbol. Okay? So how do you write S5? So the S5 now is the sigma of 2r plus 1 from r is equal to 1 until 5. And guys, this example that I'm telling you, because this is until second term, that is until third term, that is until fifth term, they are called finite or finite series. Okay, meaning you have a series that stops and a series that is definite. Okay, a series that is definite. Now, what about when you say infinite series? So let's try to look at this one. I will use the same thing. Maybe I will use this one. Okay, I have one more example. So let's say my sequence is u sub n is equal to just the same, 2n plus 1. Alright? So infinite series, meaning there's no end. So what we have said here, this is 3, 5, 7, 9, 11. 3, 5, 7, 9, 11, and so forth and so on. So 3, 5, 7, 9, 11, with this ellipsis, that is called ellipsis. Okay, so that ellipsis meaning it's continuous. So that one now is the sigma of 2r plus 1 from r is equal to 1 until n. Until n because it is not identified until which n. Okay, and what do you mean by this one? It means that it's 3 plus 5 plus 7 plus 9 plus 11 plus, okay, until plus 2n plus 1, okay, plus. What about if this is the nth term? This is the nth term. What about the n plus 1 term? Let's just write until n plus 1 term. So that will be 2 times n plus 1 plus 1. Okay, so this is now the n plus 1 term. Plus and so forth and so on. So this is what we mean by infinite series, because it is not no end. The number of terms are not specified. Okay. And then in the next video, we're going to have, for example, arithmetic progression and then finding actually the sum of the series. Later on, guys, in the future, this series, you need to take the sum. And that sum can either be convergent or divergent. When you say convergent, there is a sum. When you say divergent, there is actually no sum. Okay? Now, I'm going to give more examples about these. So let's say, for example, I have this one, the example in your book. So let's say I have 1 minus x plus x squared minus x cubed plus x to the fourth minus x to the fifth. So the question is, write this one in the sigma notation. First, you need to observe the following. Observe. Take a look that it appears to be written as x to the power of n. Because as you can see, it says x to the 0, x to the 1, x to the 2, x to the 3, until x to the power of 5. So it appears to be like this. Okay? What is the second observation? The second observation is that it is alternating the sign. Positive, negative, positive, negative, positive, negative, positive, negative. So when you make a series, you need to consider both of these. So let us try to consider first the second observation. The second observation is alternating signs. Alternating. If it is alternating, it means you need to write -1 raised to what? Is it raised to r? Is it raised to 2? Is it raised to 3? It's raised to what? Okay? Let's say, for example, if r is equal to, because here it begins with, the sequence here begins with 1. Okay? The sequence begins with 1. What does it mean? That is x to the 0. Okay? So it starts with 0 here. As you can see, -1 to the 0 is +1. Alright? Then somehow the next one seems to be -1 raised to 1 because it says positive, negative, then positive again. So that's -1 raised to 2. So basically, if you continue with that, it seems to be -1 raised to r, wherein the r begins with 0. So the sigma where r begins from 0 until when? Until 5 because you only have there until x to the power of 5, right? So, that is for your second observation. The other observation is, the first observation is this. So it appears to be that it is x to the 0, x to the 1, x to the 2, and so forth and so on. So what is that one again in that form? That is x raised to the r. Okay, so you just need to change this n into r. This is now our answer. Okay, that is now our answer. I think this one is clear. Now you can try to do question 7.2. Okay, thank you.